You're about to learn how to create and work with threads in C#. But first, we need to cover a few terminologies. A process is a program in execution, meaning when a program is selected by the operating system scheduler to run on the CPU, there it becomes a process. And process or any processes always have a thread. It is called the main thread. Now, a thread is a unit of execution within a process. It is what is being executed by the processor, and any program you write in C++, Python or Java, they always have one thread, which is the main thread. But you as a programmer, you can create your own threads and work with as much as you want. Now, when you have a multi-core device, you can achieve concurrency, which is when multiple pieces of code execute together. How to achieve concurrency? Well, with multi-threading, where multiple threads execute together. Now, this is one way of achieving concurrency. You can do so with asynchronous functions and parallel programming, but today we will cover threads in C#. Alright, so to create a thread, we first need to import the threading library that comes under the system.threading library. Now, by default, your system actually imports it by default, so you don't need to write the statement. You can just directly go ahead and use the thread data type. So the thread data type is the following. You write the thread, and this is the data type. Now you specify the name of the thread. I'm going to say T1 and equal to new. Now you could say new thread like this, or it's a shortcut which is using new. Now we're getting an error here. That's because any thread you create must get, or you must pass it a function or some work to do. So I'm going to say fn, a function. But we don't have fn, so let's go ahead and create it. I'm going to go down here and say void fn, and this function will simply say console.writeLine the following, but what it will do is it will print the ID of the thread. How to do this? Well, you're going to use the thread static class and use the property called current thread, and inside this you're going to access the managed thread ID. This is how you print the ID of the currently running thread. Now, this is a custom thread, and if I run my code now, nothing will happen. That's because I didn't start that thread. So I need to start T1, and how to do this? I need to say T1.start. So the start function allows you to run a thread, or to let this thread know that it needs to work now. So if I go ahead up here and execute my program, you can see the output, which is 12, which is the ID of my current thread, which is T1. Now, we know how to create a thread. It's super easy to do so, but we need to see how really threads work together. So how about we delete everything and start over? Let's say I want to print patterns from different threads. So I want to first create two threads. Let's go ahead and do them together. So I'm going to say thread T1 equal to new and thread T2 equal to new. You know now how to create threads. It's very easy. Now let's say I'm going to have down here a function called print patterns, and it will receive a char pattern. A pattern like, for example, asterisk sign, plus sign, minus sign. So I want to print a pattern on my console. So there's what I'm going to do. I'm going to say for int I equal to 0, I less than 100, I plus plus. So I want to print these patterns 100 times. So I'm going to say console.write and pattern. These patterns could be asterisk sign, plus sign, minus sign, whatever. Now I'm going to go up here and pass those threads the function. Now you remember that when we pass a function to a thread, we usually write its name like this. But now we have a function that accepts a parameter. So what should we do? So instead of writing this way, what we could do is use lambda expressions, also called arrow functions in some languages, or anonymous functions. So what you will do is you will pass an anonymous function and an arrow, and right here you will write print patterns and specify the pattern that you want. For example, T1 will print asterisk signs. However, let's say T2 will print, for example, plus sign. There it is. So we pass the functions to the threads. Now, I want to teach you something else. Let's say I want to name that thread. I want to give a name to T1. I could do so by actually modifying the name property. So right up here, I could say name equal to, for example, thread 1. Now, I could do the same thing for thread 2. So name equal to thread 2, like this. So both of those threads now have names. I could go down here, for example, inside the print pattern, and before the for loop, I could print which thread is currently executing and the name of that thread. So I could say console.write, and let's say write. Okay, and here I'm going to use the thread static class and access the current thread property and access the name so I could know which thread is actually running. Now I just want to format the UI. I'm gonna do this the following. I'm going to say thread.currentThread.name, and I'm going to pass this arrow function, or excuse me, just this arrow, to simply format the UI. Nothing special about it. Now, if we want to run a thread, what should we do? Well, we need to use the start function. So I could say t1.start and t2.start. Like this, I am starting those two threads together. Now remember, when we use multiple threads together, they can actually run together. They could achieve concurrency, which is when two pieces of code run together. So when we are running those two threads together, we are achieving concurrency. And we could see this in the output right now. So I'm going to run my code. Let's see what will be the output. So as you can see, thread 1 and thread 2 are executing together. And you can see this output, there's a mixture of plus and the asterisk sign. That's because those two threads were actually running together. Now in this output, you cannot really see the true parallelism or concurrency, but those two threads were actually running together internally. So keep in mind, those two threads were running concurrently, meaning together. Well, what about the main thread? Where is it? So let's go ahead and see where is the main thread. The main thread is anywhere outside those custom threads. So basically right here, when I write some code right here, this is in the main thread. I am inside the main thread. If I say console.write line anything, an empty string, this is inside the main thread. So the same thing, if I say print, for example, patterns, the function that we executed or that we have down here, and of course I need to pass it a parameter. For example, this one will execute the minus, or excuse me, this is a char. So this one will print a minus pattern. So this right here will execute inside the main thread, and I could go ahead and name this main thread. So everything here is outside those custom threads, they are inside the main thread. So if I go ahead and say thread like this, so let me write the thread correctly, thread.currentThread.name equal to main thread. This is the main thread, guys. So right here, this will execute inside the main thread. Now I notice this one is a bit annoying, so I'm going to take it off. So if I'm going to go ahead and run this program, let's see what will happen. So I'm going to run this program, and we could see that all of those threads are running concurrently. They're running together. Let me run this program and let's see a different output. We will definitely see a different output. So you can see each time we have different outputs, but either way, those three threads, the main thread, T1 and T2, were running concurrently. This is the power of threads in your application. So you now get the idea. Threads can work together, can run together and achieve concurrency. Now let's say I want T1 and T2 to execute and finish, and then I want to execute the main thread. Can I do so? Well, yes, you can. So what function should we use in order to achieve this? Well, I could say T1.join, T2.join. When you use that join function, you are saying that I want the function, or excuse me, the thread that is calling the join function to execute and finish, and what comes after it must wait until the one calling join function finishes. So here I am saying T1.join and T2.join. That means I want those two threads to execute and finish, and what comes after them will execute after they finish. So let's see what will be the output. So you can clearly see that we have thread 1 and thread 2, they run together, and after this, when both of those two threads finishes, you could clearly see that the main thread is after them running. Now watch this. What if I delete those, and before starting T2, I'm going to say here T1.join. What do you think will happen? Well, what I'm saying here is that I want T1 to execute and finish, and when it finishes, T2 and the main thread will run concurrently, meaning together. So let us see what will be the output. So you can see that thread 1 executed, it finished what it needs to do, and then what happens after it? Thread 2 and the main thread executed together. You can clearly see it right here. So keep this in mind. The join function allows you, or allows a thread who is calling it, to execute and finish, and the threads or whatever comes after it can execute once it finishes. So yeah, this is the join function. Now, instead of the join function, we could use the sleep function. I could say here thread.sleep, and to access the sleep function, you need to use the thread static class. Now, I could go ahead and specify how much time I need to sleep before executing what comes after thread 1. So I could say, for example, sleep for 2 seconds or 1000 milliseconds. Now you could write this way, or you could use the time span.from seconds, and you could specify 2 seconds right here. Both of those actually work. So let's see what will happen. So I'm expected to run T1, like this, wait for 2 seconds, and then concurrently run T2 and the main thread. So this is the sleep function. It allows you to sleep for a certain amount of time. Alright, this is everything you need to know about threads, or to get started with threads in C#. So if you enjoyed this video, make sure to like, subscribe, and I will see you in the next video.